Okay, now we're going to talk about the TVT Smooth Marine Motor. We've made some improvements to this design based on the application experience we've had to make it as absolutely indestructible as possible. We're going to talk about the VFD and what kind of performance testing we've had and show you the charts on that. So we have a resin-filled stator, fills all the way up to the terminal box, and no chance for water to ingress from the top. We use a sealed ball bearing. It's an electric motor grade, AMEC 5 or better precision. SKF and NSK are typical suppliers for these. It's grease for life. You're never going to need to replace these ever. We developed a special non-tap through B14 cover, so even though you should use thread sealant whenever putting dissimilar metals together to seal your threads, you don't need to for water ingress because water cannot pass through a solid system. We have double lip grease back seal, so I have a garter spring on a single lip on the output side next to the gearbox, then a single inboard seal, then it's packed with grease, and then it goes to a sealed ball bearing. So for water to get through the shaft seal while it's spinning or sitting still, it has to go through a spring seal, a secondary seal, and a whole bunch of grease, and then the ball bearing that's pressed into this raceway here. So between the O-ring, the shaft seal, the sealed mounting screws, I think our chances of getting water into this motor are very, very, very low. And we've had experience with this on tugboats for the monitors, and we don't have water there. And I'm sure we're not going to have it on a lift. So we've kind of overkilled it. All right. Now there's some concern about, VFDs are not delivering the full amount of torque or yada yada. Three-phase motors are more powerful than single-phase. We can deliver torque on 3 different phases, not a couple shaded phases, if you will. So we did some testing because there were some concerns there to see just how much torque are we developing. How many kilowatts are we asking out of this 1.1 kilowatt? And is the cycle too scary for it? Is it just too much? So we cycled it on full load to break down torque for every 2 minutes, and then rested for 8 minutes. So 2 on, 8 off, 2 on, 8 off. Now on that'd be about 23 feet in a typical lift per cycle. So that'd be up 23 feet, up 23 feet, up 23 feet, up 23 feet. Well, a typical lift goes up, and it goes down. All right, so this is a more extreme situation than what a lift would actually see. And it's also seeing it like the lift being not only full load but overloaded, just to see, is it delivering the torque and the horsepower that's required for the load, or is there something else that we're not aware of that's asking for more than what the motor or the drive and the gearbox are rated for. So we did a worst case scenario cycling, and these are the results. Our external temperature, the room that we're testing, is about 70 degrees. We raised up to 77 degrees, but you can see from the green line we just really didn't get hot. In that duty cycle, temperature is not a problem. Now I know in the application we can get really hot. The watts of power we developed, 1734 to 1740. That's 2.42 to 2.4 horsepower. This is a 1.5 horse lift. Okay, so we're almost doubling what's required, which is what we expected that we would see based on the VFD's ability to deliver overcurrent for 2 minutes. So after I reached on the input of 11.49, so that's a single phase going in. The output amps are measured differently because it's in 3 phases. So you're seeing about 4.7 output. But again, right within parameters. Our voltage did just like it should. So when you load the motor, voltage drops a little bit, and then when it goes to the rest state, the voltage climbs back up. So that was completely expected, and the motor and drive package actually overperforms its specifications. In actual cycle testing, it did better, more than what it was required of. I mean, if it's doing more than that, if there's more load than that required, then we need to look at what we're lifting and how much cable pull we have. And I'm looking to get data on that. But The smart lift system and the TVT smooth marine motor for lifting applications obviously tests out well within parameters expected. So next we're going to take and go from the testing in the inside of the motor, and we're going to look at what kind of improvements we've made to the outside of the motor to make it better for this application. So we've moved our control power and cables to the bottom, and on the top right we've got a sealed port for the optional brake control wiring. So you can put our modular brake on the output of this motor and then just feed the power over to this port, and then internal to the I2C option board that we've designed to work with the smart lift system. Use the one-piece cast aluminum motor housing, so that's all unitized, and then it mounts to the cover, which we just discussed with the O-ring seal and the sealed output shaft seal and the non-tap through B14 taps and all that. So it's very strong, but yet it's watertight, perfect for marine applications. And we have our 4 to 18 megahertz FCC certified RF antenna. Gives us about 600 feet, 700 feet of range. It's much better than our competitors. We have a 2400 megahertz FCC certified Wi-Fi and Bluetooth antenna. Same range, about 600-700 feet. You can connect to it with your home wireless internet or your cell phone with Bluetooth, as long as it's 4.0 or newer. You can connect to it as Bluetooth Low Energy. It's the latest and greatest, but most iPhones and Android phones can connect to it. We improved our seal. It's a minimum half-inch wide, 1/16 of an inch thick. It's made out of a nitrile rubber. Gives us an IP66 seal. Here's where we put our 240 volt single phase input and our dual Cat 5 or 6 Ethernet ports with our cable glands. The idea being that if the seal was to fail for some reason, the installer did it wrong, and we got vertical rain, so rain's not going sideways or down, it's going up. Well, if water did get through here for some reason, it would drain right out the same spot. Plus the VFD is on the very bottom, and that has the conformal coating, so it's got a certain measure of water resistance to it already. And it'll mount to the frame and look nicer by having it sit here on the bottom. And this is how the motor and the drive is mounted in the application. So it's going to look good. It's going to be watertight. We put our antennas underneath there so they're less likely to get water. We silicone back those. So the whole thing is designed for the application. It's designed to remain dry and functioning. Next we're going to talk about is a special TVT gearbox with low back drive that we developed. So has a die-cast aluminum alloy housing inside. It's got a ductile iron output bore, and it's got a chill cast SA 68 bronze gear over it, and then over that's a case carburized and ground worm. So we have a decent baseline of efficiency, but we have high strength. We use stainless steel fasteners with thread sealant on all the screws, so that we don't get dielectrics and we don't have any kind of leaks throughout the system. And it's a nice smooth housing with no places for water to live. And we have a cap on one side. The other side goes to the flange that mounts to the head pulley, or the winder, as they say. And the input, we've developed a special dual grease pack Viton seal. So Viton is a DuPont special chemical that has a wide temperature range. The notes are in the presentation. It's something like -30 to 100 degrees Fahrenheit or Celsius, which is very, very cold to very, very hot. 100 degrees Celsius is 212. It's boiling. But you have synthetic grease, then a seal, then grease, then another seal. And you want to have a small seal diameter on the input. Now, I know there's a competitor out there that has made lifting gearboxes, and they have a large diameter seal. The problem is that shaft is turning 1660 RPM, so it's your fastest wearing shaft. It turns something like, in ground speed, it's about 5.6 miles an hour. Now, the output seal is turning 80 times slower. So that's turning like 650 feet an hour. So your input seal is the thing that's going to wear out first. Well, top on that, this is facing down, so it's flooded in oil at all times. So you don't want to have a gearbox with a single seal with no grease dam that's big in diameter sitting on the bottom of your gearbox flooded in oil. When they leak, nobody should be surprised. So we designed this special seal for our low backdrive gearbox so that it wouldn't leak. The other thing we did is we added additional shims to the gearbox, so when it starts, it's going to have a very low initial backdrive just out of its design. So we're moving the worm gear axially into the brass gear so that it reduces clearance and it makes the gear tight. Now the bad part of that is it does reduce efficiency. This gearbox is rated for 1,600 inch-pounds of torque, and we're developing at constant load, and we're developing about 2,100 inch-pounds of torque out of the system. That's okay in this application because it's intermittent use. If it was continual use, we'd need to upsize the gearbox. So for this application, sizing it, it's got about a 0.75 service factor, which is acceptable for this particular application. Now, if we're going to go to heavy lifting commercial applications where we're constantly going up and down, we might like to look at a larger low backdrive gearbox, go from a size 75 to say a size 90, just for that factor. But anyway, we have excellent capabilities based out of this. Like I say, at a 50% efficiency, we're seeing about 2,160 inch-pounds of torque. Output seals are double lip rubber encased. It's a nitrile, it's a DuPont synthetic rubber. It's got a garter spring on the inside, keeping the synthetic oil in, and it's got a wiper lip on the outside that keeps contaminants out from underneath the seal. We plunge ground all of our sealing surfaces. Plunge grounding makes it so that you don't have a thread on the shaft, so your lips don't go out or go in when this thing turns, and it keeps the gearboxes from leaking. It's just an extra little feature that we do that makes the gearbox oil tight, and you won't see leaks out of a TVT gearbox. We use liquid gold, basically. It's the most expensive stuff I've ever seen. Shalimala S4320 synthetic oil. And I'm sure there's all kinds of less expensive things out there that you could use, but we have over 20,000 hours of service life for this product. It's fantastic. We don't have any degradation of anything, and although it is expensive, our gearboxes take just a small amount, and our customers should never ever have to replace lubricant. It's not like a lawnmower where you change it every year. You should pretty much install your legacy lift and run it. You don't need to change the oil. About the only thing you might want to look at after a number of years would be the input seal, because it's turning so fast, but that's even that is pretty well designed, and I don't see maintenance within 20,000 hours. So 20,000 hours in continuous use is about 5 years. So it's 8 to 1, 1611 inch-pounds of rated torque, 0.94 horsepower, with service factor with a 1.5 horse motor is 0.62, output torque estimated at 2160, service factor of 0.75, as I already said. But that's the kind of numbers we're generating. So if you have a 2-inch winder, you should have 2,100 pounds of cable pull. If you have an 1.5-inch winder, it's going to be about 40% less than that. If you have a 3-inch winder, 1.5-inch radius. So the farther you go out on your radius, you have less cable pull, but the torque is 2,160 inch-pounds based on 1.5 horses. And you've seen from the testing, we're developing and have the capability of developing more than 1.5 horses here. So now we developed something that is new. It's a low backdrive cap, and I'm calling it the BAC. We made it so that you could take 4 screws out after the gearbox is worn in, and say you're starting to notice backdrive. So you take and unscrew these 4 screws, put a little shim in, and then press it back in or tighten it back up. It's got an O-ring seal, so you never have to replace a paper gasket or anything like that. And you can just move the gear axially and reshim the gearbox. As simple as that. It's maybe a 5-minute job. Just I think it's an 8mm wrench, and no fuss, no muss. So that's an option we're offering. The Legacy Lift, an exclusive product to the SLS system.